let's have a look at this one here. So first we just want to draw the equipment you need for the experiment. So you're going to need an insulated calorimeter with a lid, and then the thermometer in it, and then the olive oil, and then the heating coil, and then that can be connected up to an ammeter to measure the current, then a power supply, and a switch, and a variable resistor to change the current, and then you need a stopwatch because it has to be three minutes, and then you need we'll make it three-dimensional. Then you need a digital scales, and then you need a thermometer for the room, measure the room temperature. So that's an insulated calorimeter. That's a stopwatch. That's a thermometer. Sorry, I'm squishing this in. Stopwatch, weighing scales, a room thermometer, variable. These are all standard symbols, and that's a heating element. And the olive oil is inside. And the olive oil is inside. I think I got everything for that experiment. Okay, 2. How is the mass of the olive oil determined? As the mass of the full calorimeter minus the mass when it's empty. Okay, 3. Draw a suitable graph to verify Joule's law. So Joule's law is Q as a proportional formula version of the law. It's Q. Delta theta is proportional to I squared. Because the formula is delta theta equals or I squared t. So what we'd have to calculate on our what we'll have to do to our table is we'll have to calculate I squared in amps squared and the change in temperature delta theta C. So the first one would be 1 squared, which is still 1, and the change from 17 to 19.2 is 2.2, and then 2 squared is 4, and then the change from 17, what's that, 3, is it 9.1, is it? I think. Etc. Etc. So our graph we make would look like this, where you would put the delta theta values in Celsius on the x-axis, and then the I squared in amps squared on the y-axis. And yes, although I guess you could put it the other way around, because the independent variable is the delta t is the I squared. So I actually would prefer to put it the other way around, but I wonder what most people do. Let's do a quick Google to see. Plot Joule's law, current squared, and change in temperature. Whoops. Yeah, delta theta here, I squared here. Delta theta here, I squared. Yeah, that's what I thought. Let's have a look at one more. Oh no, it's temperature and time. Temperature and time. Yeah. Yeah, I actually think it would be more appropriate to put them the other way around. The I squared should go here in amps, and the delta theta would go here in Celsius, because this is the what's called the independent variable, meaning the variable you change in the experiment, and you change your current here by adjusting the rheostat here, and this is the dependent variable that goes on the y-axis. It's the thing you measure in response to the change in current. So yeah, no current means no change in temperature. So when you plot the points 1 and 2.2, 4 and 9.1, should end up getting a straight line that goes through the origin. Okay. 4, calculate the slope. Now the slope is going to be the rise over the run. So what you do on your graph is that you draw a big triangle anywhere you like. Roughly 3/4 of the data should be captured by it, I think is the recommendation, something like that. So like don't make it too small, and I guess you don't want to make it too big, but I can't really see how that would be as bad as making it too small. Make a decent sized triangle and measure the length of the rise and the run and divide them to get the slope. Now I'm not doing that properly right now. I'm going to have to look at the solutions to see what that value is. 447, but the problem is I do not know which way around they did the plot for that 447. Did they match up with mine, or do they have the x and y the other way around? It's really not helpful. I'll fill it in a moment. Okay. And 5, calculate the specific heat capacity. So Joule said that, the formula heat energy required to change the temperature is Q equals mc delta theta. And also Joule said I guess I could just sub that in directly, couldn't I? But Joule also said that Q equals or I squared T. I actually wrote that wrong symbol there, sorry. That's not what Joule said. Joule's formula without a proportional is Q equals R squared IT. I'm pretty sure of that. That's Mr. Google. Yeah, Q equals I squared RT. That is it. I wrote delta theta by mistake. Okay. Although I guess there was no marks going for that. Okay, so I can equate these formulas. I get mc delta theta equals R I squared T, and then delta theta divided by I squared. So I'll divide by I squared, get rid of that, divide by mc. So then I have R times T over M times C. And the reason I did that is because delta theta over I squared is actually the slope, something that we worked out. So then we get slope equals RT over MC. Let me rewrite that, RT over MC. I'm looking for the C. So I'll bring the C up here, and then I'll bring the slope down to be with the mass. So C equals RT over slope times mass. R times T over slope times M. Now I'll find out if the slope is right or wrong, or which way around they have it. Let's have a look. Let's see if 447 works. 8.5 times 3 times 60 over 0. What did I say? 447. 447 times the mass, 0.35. No, now that is 1 divided by 1954 joules per kilogram per Kelvin. So that means the slope for my graph is 2.237, and it's Celsius per amp squared. Almost lost a mark there. Celsius per amp squared is my slope. Now that's weird because it means that in the marking scheme they have the graph the other way around, I squared on the y-axis and delta theta on the x-axis, which is strange for two reasons. Number one, you usually put the independent variable, the thing that you change, on the x-axis, so that's strange. Unless there's a good reason to have it the other way around. And number two, this doesn't seem to be how most people, at least on Google, are doing it. Let's one more search. Joule's law, current squared and change in temperature graph. Let's see what it's giving me. Not quite the same results as earlier. I must have typed in something different. Yeah, okay, this graph here is the other way around, although it's not current actually. Current squared, it's current. Current temperature plot. Temperature resistance. No, I can't find the results I had earlier. Joule's law, here we go. Yeah, that's I squared and delta theta, yeah. And here's another one. I squared and delta theta. Yeah, I feel like I've done this a little bit better than the marking scheme. Heating coil I have, power supply I have, ammeter I have, thermometer I have, and more. The mass is correct. I squared and delta theta I have. Label the axis, and I have to have the units correct. I almost lost a mark there. Correct points plotted and line of best fit drawn. I calculate the slope, but my number wasn't this because mine are the other way around. And I calculate the heat capacity here. So yeah, okay. That's that question done.